Hi everyone. Now let's add a new microservice called Reactive Elastic Query Service. Then as usual, I will start adding dependencies. I will start with local dependencies, which are query service common, app-config data, and elastic model. I will put all dependencies here that we will need for reactive version of query service. And the difference from the previous query service is that we changed the Spring Boot Starter Web to Spring Boot Starter Web Flux. And also here I removed the Elastic Query Client, HeyToUs, and OpenAPI dependencies for simplicity. So here I will simply focus on reactive version of Elastic Query Service. Then I also add Spring Boot Starter Data Elasticsearch to use for Elastic repository. Finally, I will add Cloud Starter Config, Starter Security, Lombok, and Starter Test dependencies, which are required in the service. I removed HeyToUs and OpenAPI dependencies since I want to keep things simpler for the service and focus on the reactive implementation as I mentioned. Here I also added Spring Boot Maven plugin, as I did for other services, and just changed the Docker image name. Now let's create a package, com microservices demo reactive elastic query service, and add the Spring Boot application class, reactive elastic query service application. As usual, I will use Spring Boot application annotation and component scan annotation here. And in the public static main method, I will call Spring Application Run method. Then let's add application YAML configuration file and add the config server repository file for the service called config client reactive elastic query YAML file. Here I will put the same properties from the non-reactive version, except that I will use Spring Web Flux base path and use codec to set the max in memory size, and use Spring Data Elasticsearch Client Reactive Max in Memory Size properties. Both of those properties set the max size limits, and it is defaulted to 260 kilobytes. Here I set it as 25 megabytes to be able to work with large data. I also set a back pressure delay as 500 milliseconds here, which will help us to add a delay for each record and return it in chunks to the client. Let's also add Bootstrap YAML file for config server properties. After adding config server properties in the Bootstrap YAML file, I will add logback XML file for logging as usual. Then I will add Reactive Elastic Query Service Application Test class for context load test. Great, now I will first add a config package and add a simple security config class for Web Flux security. I will not apply any security here for simplicity. So create a method called Web Flux security config to create a security web filter chain and permit all and then disable CSRF. So here I simply allow all requests using the permit all method. For model transformer, validator and exception. I need the same files from non-reactive version, so I will use them from the common service module that we have created in the previous section. I will not use the query client module we created, so I will create a repository package here and create Elastic Query repository by extending reactive CRUD repository with Twitter index model and string for the generic variables, and annotate this with repository annotation. I will create a single findByText method here, which returns a flux instead of a list. Flux is simply a stream which can emit 0 to n elements. And in general, mono and flux are reactive elements, where mono emits 0 to 1 element, while flux emits 0 to n elements. Now let's create reactive elastic query client inside business package with a generic type T that extends index model. And add getIndexModel_byText method here to return a flux object. Then create an implementation class, Twitter Reactive Elastic Query Client, and I will annotate this class with service annotation, and then use Twitter index model for the interface generic type here. Then I will create a log variable and inject Elastic Query repository and Elastic Query Service config data. Then override the getIndexModel_byText method. In this method, I will first log an info message, and then call repositories findByText method, and add a configured delay to create a back pressure here. Finally, I will return a flux object in this method. For this one, I need to use config variable that we defined. So I need to update the Elastic Query Service config data with back pressure value for config. Let's do that. And at this point, let's also commit and push the config server repository changes. Now I can use the back pressure configuration value in the query client. Then let's add Elastic Query Service interface to use it in the controller and delegate the call to repository. And add a single method getDocumentByText that will again return a flux object of response models type. Then I will implement it with Twitter Elastic Query Service class. I will annotate this class with service annotation and create a log variable, then inject reactive elastic query client and transformer. I will log an info message first and then call the method getIndexModel_byText from the reactive client. Then I will simply map the returned results from elastic model to response model using the transformer class. As you see, I always return flux so that I can use the reactive streams. Let's then create an API package and add controller class. I will annotate this class with request mapping annotation with path/documents. And also I will add REST controller annotation to make this class a REST controller. Then I will create a log variable and inject Elastic Query Service object. I can then create a single method here, getDocumentByText. I will add post mapping to these methods with getDoc_byText path. The most important difference here is the produces property. It has media type text event stream value, which will actually make this endpoint an event stream endpoint and return the response by chunks to the client. Here I also add valid annotation to the request body to enable validation. And inside the method, I will call the getDocumentByText method for Elastic Query Service. I will also use log method on response, which observes all reactive stream signals and trace them using logger support. Then I will log that we are returning and return the response as a Flux object, which includes our response model. Now I can run this service after running the config server. When I run this service with info log level, I will see that Spring Boot automatically configured Reactive Netty as the default server. Reactive Netty is an asynchronous event-driven network application framework. It provides non-blocking clients and servers. So instead of Tomcat, here we use Reactive Netty, and it comes by default by Spring Boot. Let's try to call the API on Postman and check the logs. As you see, I get the results. So I need a reactive client to see the results in chunks. And in the next lecture, I will create it with a reactive web client to see those chunked responses on the web browser. Alright, I will see you in the next lecture.